Chapter 13, number 58. A simple pendulum of length 2.8 meters makes 5 complete swings in 37 seconds. What is the acceleration of gravity at the location of the pendulum? So let's identify what we know. We have the length L, 2.3 meters, and we have a total time of 37 seconds in with a number of cycles, which is 5. And finally, what are we looking for? Well, we're looking for the acceleration due to gravity, which we would call G. I'm going to call it G effective because we don't want to confuse it with our symbol G, 9.81 meters per second square. All right, so we have a length and almost a period, so we're probably going to want to connect that. So we're going to say the period is the total time taken over the number of swings that happen. In other words, there are 37 seconds to do 5 complete swings. So that period is 7.4 seconds. And we know we have random mistake figs, so we're okay. And then we're going to use the so-called mass or period length condition. Relation, really. Which is that the period is 2 pi, that weird factor of 2 pi keeps showing up, times the root of L over G. So we can square both sides and get t squared equals 2 pi quantity squared and the square root of L over G quantity squared, which is 4 pi squared L over G. And then we can multiply both sides by G and divide both sides by t squared. And that leads us to an isolation where we have this G effective. And I guess we really should be consistent here. This is really G effective in each case. We get that G effective is 4 pi squared L over t squared. Which now we can just put in numbers on. 4 pi squared times a length of 2.3 meters over a period of 7.4 seconds squared. And we end up with 1.658 meters per second square, which I guess really comes out to be 1.66 meters per second square, which circumstantial evidence gives us that this is probably on the moon because G is about 1/6 of that on Earth.